Welcome to another episode of Rustacean Station. We're talking about This Week in Rust issue 442. My name is Tim McNamara and I am with co-hosts Sean and Alan. Do you want to introduce yourself, Sean?
Hi, I'm Sean. I guess my relevant credentials here are I produce the Building with Rust podcast. Alan?
That's me. So you may hear me on this podcast producing the weekly Friday interview section.
Cool. It's so great to have you guys with me today. Hopefully I won't embarrass myself too much. The format for today's episode will be that we will start with the quote of the week and chat about the official updates. And then each of us has picked a couple of items that we have selected from the rest of the newsletter. If there's time, we might touch on a few other things, but we're not going to cover the whole newsletter itself. You can go and read it. We have a link to the blog post in the show notes, and you're welcome to read along with the commentary. Okay, so let's start with the quote of the week, which is right down the bottom. It's a comment from a Cloudflare staff member. At Cloudflare, we have big Rust projects and teams, and we onboard new developers regularly. There is a learning curve. Rust is rigid and unforgiving, and noobs need assistance when the compiler says no. Although error messages and Clippy do a good job for common mistakes. However, the big upside is that new developers can contribute safely to Rust projects. Rust limits the severity of the damage an inexperienced programmer can cause. Once they manage to get the code to compile, it already has lots of the correctness guarantees. Bad Rust code may just be a clone more than is strictly necessary, or you might need to write 10 lines of code for something that has a health method in the standard library. But you won't corrupt memory or blindly run the happy path without checking for errors. Rust prefers to be locally explicit, and so it's also easy to review. So that's quite a long quote, but I thought it was a nice way to start.
Yeah, I like how it rips on noobs. It's really interesting, but also says good things about them. I thought that was a little bit surprising to use the word noobs in the quote, but I understand his meaning.
It's kind of slightly distasteful.
Doesn't seem very Rust-like to use this kind of term, but that's why I was a little bit surprised.
There's a lot of nodding of heads here in the remote recording studio. Sean is based over in the States, Alan's in Hong Kong, and I'm in New Zealand, so we're kind of crazy in some ways. Okay, so there are two official updates in this week's newsletter, or have been posted. One is a security advisory, and the other is an agenda for the cross-team collaboration meeting. So let's chat about this security advisory first. The context here is typo squatting inside crates.io. So a spoof of the rust_decimal crate called rustdecimal without a space injected potentially malicious code. So what, if you were interested in the details, this new crate had exactly the same API surface and in fact only had one change, and that was the constructor method for decimal type would go and check an environment variable to see whether or not you're running inside GitLab CI. And if you were, it would go and download an arbitrary binary and attempt to run it. This was detected by... So I think there are really two interesting things about this episode. One is how it was detected, and the other was how detected and reported, and secondly, how it was sort of remedied. Caio Fernandes, a Brazilian developer, sort of just tagged people in a GitHub issue as the mechanism for reporting the problem. So just pinged people inside GitHub who he knew were members of the crates.io team. I want to point out, if you detect a security issue within Rust, you should email security@rust-lang.org. That's the primary mechanism for reporting errors. So there was a bit of a process flaw there. On the crates.io side, once they detected the issue, the crate was yanked from crates.io. There was an attempt to sort of conduct an analysis. Roughly 500 downloads of the malicious crate were found, but it was probably most of those were automated checks because the Rust compiler, for example, its regression test involved downloading every single crate and crates.io and attempting to compile it. And so I presume that those 500 downloads weren't bad. Anyway, so that's the security advisory. Did you guys read this? Did it raise alarm bells for you?
I just thought it was funny how the post mentioned that the binary payload affects Linux and Mac users, but not Windows. It's like really ironic. And how, like, in this small instance here, Windows is getting the last laugh as far as like a virus or a malicious piece of software is concerned.
Yeah, it's like, well, this is a developer audience, right? It's you can just imagine, you've got your rootkit that you've designed, and you're like, well, I kind of can't be bothered with Windows today.
I'm kind of curious what would happen to that user, right? If there's anything that could happen to the guy who actually created the package, what kind of things could happen? I mean, that's the one thing nobody's talking about, right? We should be able to find something like this, right?
That's a good question. I mean, it's illegal, you could go to jail, but enforcing security issues across boundaries, across legal jurisdictions seems extremely difficult. This may be a good time to chat. I don't know if we want to spend any time on it, about some other areas where crates.io and maybe Rust could be strengthened in terms of its security story. I'm thinking specifically around like build.rs and its ability to kind of do anything. But actually what I'll do is postpone that for the top picks chat, because that comes up a lot in those. So yeah, I think enforcement is a really difficult challenge, and sadly, there's very little, I think, that you could do. At least that's my understanding. Okay, so the next official update is the CTCFT 2022 May agenda. So what is the CTCFT? The Cross-Team Collaboration Fun Times. So this is like almost intentionally the worst acronym everyone has ever created. I don't know.
I mean, Nico came up with it. I think he has a bit of a reputation to uphold as far as acronyms are concerned.
Right. So this is an attempt to bring all of the teams together. And this month, that is May, the focus was on the embedded working group and Rust and embedded. So there were 3 15-minute talks, which have actually been already uploaded to YouTube. There's actually a link in the show notes if you're listening to the podcast to the YouTube recording. So one was an introduction to Whirlwind Tour of Embedded Rust by James Munns. Then there was Async Rust for Embedded Systems by, and I'm going to get the Dutch wrong, Dario Nieuwenhuis, and Rust and Automotive by Christoph Petig and Florian Gilcher, or Gilcher, I suppose, other people, I guess, if English speakers would say. I haven't watched the talks. Have either of you been able to have the time to watch them?
I did not.
I feel slightly guilty. I feel like I just need like days that are about 60 hours long. I think then I might have enough time to consume everything that I want. Async Rust for embedded strikes me as something that's particularly interesting because you don't have threads in microcontrollers. You don't have a scheduler. So how could you have an async runtime? That is curious to me, but I haven't read the talk.
I'm actually even curious. I can't even really think of what are the use cases. Well, no, maybe that's a silly question. You know what? Let's retract that statement.
No, there are no microcontrollers watching, monitoring sensors or responding to events. No. Or typically it's all interrupt driven, right? So in some sense, microcontroller or embedded software is all asynchronous because you know that your process could be interrupted by an interrupt at any stage, and the interrupt handler is the thing that's doing the work, or at least it's setting a flag, which is then goes back to the main routine to do the work. But I suppose, but that isn't an async runtime. It's not the same case. It's not the same thing that you are building a web server on a Raspberry Pi and you need to be able to hit 150,000 requests a second. Okay, time for our top picks. So I'm going to throw you both under the bus and and go around. Who wants to go first? I think last week we went backwards and forwards. It makes sense to me. This week we do a similar thing where we go around and around. 1, 2, 3. How does that sound to you?
Sure.
Good.
Great. Sean, do you want to start us off? What was your top item?
Sure. So I'll start with the announcement post for the Kani project. So this is under the project updates section, announcing this project called Kani, which is the Kani Rust Verifier project, I should say. So this one's pretty cool to me. I actually stumbled upon the project probably a few months ago. I don't remember how. Probably very randomly browsing GitHub. But it's they use the term automated reasoning here. In the blog post, I think formal verification might be a little bit more well known, but apparently they're synonymous.
Had the idea that it was a model checker in like TLA Plus or Alloy, but I actually haven't used Kani at all, so I'm just excited that it's implemented in Rust.
Yeah, so it is not it's a model. I guess I'm not sure if it is a model check. I don't believe so, but it's definitely not in TLA Plus. So it is specifically for kind of like augmenting your tests, and they provide special macros and annotations to go ahead and assert logical statements on your Rust code. Another similar project in this domain that I'm also aware of and I've looked at a bit is Prousty. So I'm not entirely clear what their differences are or what the trade-offs are between the two projects, but they seem to take similar approaches to how they verify your Rust code. Again, by kind of like allowing you to kind of extend Rust and just write logic that verifies your Rust code in Rust. Which is nice because that's kind of like a huge that's one of the main pain points when it comes to formal verification tools and techniques is generally I guess that's probably one of the most common approaches right now is using having to learn a separate language like TLA Plus and to write a specification that kind of lives alongside the code you want to verify, and then you kind of have to have the whole extra burden of having to keep the spec up to date.
So you're telling me that with this, I might not have to do that?
I think it moves it more into the realm of having to like update your unit tests, or at least a lot closer to that is I think the main value proposition here, which I'm
happy with that value proposition. I gotta say, like I was gonna say, the hard thing about formal verification for me is that it's really hard. Right? Like you've got this problem where you need to be a mathematician in order to make use of these ridiculously powerful tools, or at least that's how it seems to me as someone who is not a mathematician. And I've tried, like I've read a couple of books and I've wanted to apply model checking or formal verification to some of the software that I've written. And the payoff has never really been there. Like I've never really been able to feel like it's worth spending an extra 10, 20 hours on the thing so that I can get the payoff like in 6 months' time.
Mm-hmm. And specifically this blog post, like to your point, Tim, this blog post does reference Alistair Reed's post, which is something he wrote. Alistair Reed kind of is a researcher who also is looking into formal verification in Rust. And he wrote a post maybe 6 months ago, I'm guessing, maybe more, I'm not entirely sure. But it's, again, linked in the Kani blog post. Just one of the main points that Alistair makes is specifically this, right? That one of the hardest things for developers to get over is the learning curve of when it comes to formal verification, right? The learning curve is too high. Maybe sometimes developers will have to use different tools, which is not part of their day-to-day workflow. It's just too much friction for something for a payoff that doesn't exactly seem immediate, right? Like ensuring correctness in such a robust manner, like maybe that doesn't seem like it pays off until sometime in the future, right? It's it doesn't feel like a particularly iterative process in that sense.
No, and it's interesting actually talking about that or learning a tool or a software tool from the point of payoff versus immediacy, because this is the same argument that Rust makes. This promise that your software will be more reliable or robust or faster. But if you're just doing your thing and your Rails app written in Ruby just keeps working, that is very difficult to quantify. Or, it's the same as no, it's not quite the same. But no, I appreciate the work that is being put in, and I'm really, really hopeful for this project. I think that it's great.
Yeah, I agree.
Alan,
I just want to give my few cents about this topic. From what I understand, this tool, it didn't directly say it. I found it interesting, the word that they called it, but they did directly say that they do property testing. So the way I see this is basically a property testing tool, which if you're in Erlang or Elixir, you actually know about this stuff pretty well. I think they talk a lot more about this. And it's got a very specific use case, right? So you can't just say, okay, I'm going to write my test with Kani and I'm done. This kind of testing is usually there to spot edge cases, right? I just want to make that part clear. What's the point of it? And so, like if you're writing database drivers or intensive stuff, or maybe like automotive, these kind of things, you want to get edge cases. So that's really what this kind of tool is really for. So don't think, okay, I'm writing, like you said, I'm writing my blog. I need to make sure this thing works well. Let me write a bunch of Kani tests. You can, but do you really need that? Like, is it really intensive? Will somebody die? I mean, you have to have some stuff in there, but I think it's good to put into your arsenal of tests, though. So something to augment your test, not to solely rely upon.
Alan, I don't like you insulting my static site generator. It has the same performance or strictness guarantees as medical devices.
I want to be clear. Kani is not property-based testing. So there's, I kind of want to point out the distinction, I think, between property-based testing, which you can think of as an extension of unit testing, right? So that's different from what Kani is doing, which is actually using mathematical formalism and logic. And I think the easiest way to explain the difference here. So property-based testing, what you're referring to, Alan, is basically you have a test and it is run with a whole bunch of different inputs, right? So the idea there is if we can just kind of run a unit test with a whole bunch of different inputs instead of just whatever inputs were hard coded, which is what would be the case with the unit test. And that is not exhaustive, right? When it comes to property-based testing, in a lot of cases, they gave an example in the post where it's if you have a function that, for example, takes 3 U64 parameters, that's 2 to the power of 64 times 2 to the power of 64 times 2 to the power of 64, or 2 to the power of 192 possible input combinations. And that math was all in the post. I didn't do that in my head. But
just a small number there. Yeah.
and yeah, right. So that apparently comes out to, even if you run one test case every nanosecond, that comes out to approximately 14 billion years. So property-based testing there is just not a tractable way to go ahead and even test that, a function with that signature, right? And so what formal verification opts to do instead is actually, it kind of comes at this from the opposite end of the spectrum, right? So if you think of unit testing, which is the closest to quote unquote regular software development or engineering, and then property testing is maybe an extension of unit testing on that spectrum, then formal verification comes from the opposite end, which would be again, mathematical logic, where it is doing all of this analysis statically, which is the other kind of amazing thing to me. It doesn't actually run your code, or it doesn't actually, well, I guess property-based testing doesn't run your code either, but it's interesting that it is able to do all of this analysis statically without running your code. And they actually, this post also linked another very well-written blog post from Amazon Science, which I didn't know was a thing until I read that, but they give a very kind of nice and gentle introduction to formal verification, the basics of formal verification techniques, to kind of explain this difference here again between mathematical formalism and property-based testing, and they do that very well. So if anyone's interested, I would definitely recommend that Amazon Science post as well.
Cool. I better push us along. Otherwise, we're going to be having a very long book.
Yep, okay. Go ahead.
Alan, what was one of your picks from the newsletter?
Yeah, one of my picks is, and this is something I just ran into, which is that Rocket has a new 0.5 second release candidate that came out. I am very happy for this. This is something I think that we can move Rust along with in the web development part, is that we need, like this kind of builds up on what Tim talked about last week. We want to be able to select stuff for people to use out of the gate. So you need to think about which RO am I using, which template language am I using, etc. Rocket helps to kind of solve that, saying, okay, here's Rocket, use everything inside. I think that's fantastic to have. And I know it was stalled for a long time too, so that's also why I'm quite excited. And sorry, go ahead.
I was going to say Rocket is, and just seeing the way that, is it Sergio who
yes
used proc macros? I was like, wow. Just kind of annotating these functions with just a get or a put or a post annotation. I just was like, that's extremely elegant. And it just, the difference in the Rocket approach, where it just tries to make things very easy and nice and natural, made me appreciate that given enough thought on design, software written in Rust can be as expressive and as elegant as higher dynamic languages. And the trade-off, though, is that it requires a lot of thought and often a lot of engineering, which is why Rocket has taken so long. I mean, I don't mean that in a disrespectful way. It's just really, really hard. And I'm just so enthusiastic and so grateful that people like Sergio exist in the open source community.
Yeah, well, that's why I'm excited, because this thing's been stalled for quite some time because of his some personal issues he's going through. And so I'm happy to see that it's moving forward. And I think you guys should give it a try. So some kind of notable stuff that came out is HTTP2 out of the box, what they call feature complete forms, which they're going to be able to use multi-part. Also ad hoc validations within the form. An actual async core now, so they're really totally async. And I believe this is probably one of the best things too, is that now you can run Rocket with stable. So one of the issues about using Rocket before was that you could not use stable version of Rust with it. But now we have that. And I think you guys should give it a try if you're into web development.
Just if anyone who purchased my book during its beta period will know the pain of requiring stable, because I had an example of Rocket right at the start, but it required nightly. And this caused a lot of people getting quite angry at me. So I actually had to pull it from the start of the book. I should move on, though, to my pick, which is a post from Rafe Levin. He has created a new architectural design called Xilem, which he calls Xilem. And I chose this post not just because of its content, but almost mostly because of the individual who wrote it. I have the utmost respect for this individual who it just has the most amazing career. So I just want to spend a little bit of time geeking out about Rafe or Raf. So imagine just waking up and thinking, I need to redesign the internet. So he created a social network, and I really like curves and fonts. And so I'm going to also create a vector image program. So it creates Inkscape, goes to join Google, it goes into the Google Web Fonts and kind of engineers that out, and then does font design or font engineering in Android, also created fonts and has a font creator. Finishes his career sort of he also was the person, if I understand it, who really advocated very strongly for Rust inside Google, and in particular in the Fuchsia project, with the Fuchsia operating system. And it's sort of at the peak of his career, decided, I'm going to quit and create a synth. So he really wanted to create an audio synth as like a personal project, and also really wanted extremely low latency text editor. So he created the Xi editor project and has gone through multiple iterations of building UI toolkits or frameworks for building UI toolkits so that he could build his synth or so that he could build his text editor. And with almost ridiculous performance requirements. So both the fastest as well as the nicest looking everything. Which actually brings me to the post. So like, what is Xilem and why not anything else? So one of the things that is really compelling about Raf is that he writes very thorough and very well thought out blog posts. So this would have taken a long time. We've got, and there, before describing his own approach, he discusses the limitations of the others. So there's a survey of Druid, which his current, or which is, I guess, the attempt from a year or two ago. And he's saying, look, it's good, but it's kind of unwieldy in practice. That was kind of summary and we've got immediate GUI, which is really good as well, but it has a different problem, and that it's very difficult to do sophisticated layouts and very sophisticated things. So it's not quite enough. There is the Elm model, and again, it's really good, but except it doesn't include support for components. In fact, there is some commentary inside the Elm documentation that says, do not attempt to create components in Elm. It won't work. And then there's kind of the React model, of which the latest project is, I guess is referred to as Dionysus or Dioxys as a Rust project for building UIs. And the problem there is like it's excellent, but it relies on interior mutability. And that kind of goes against the grain of Rust. So can we do something different? And this is his attempt at doing something different. Xilem seems to be very heavily influenced by SwiftUI, but instead of relying on dynamic dispatch, it's all compile time type inference. And the composition of types and traits is all very elegant. But I don't know much about designing UI toolkits, so I can't actually critique any of the content. It strikes me as good. That's about the level of commentary I can provide on the actual specifics. Were you guys able to catch like any thoughts on that?
I have kind of seen Raf in the ecosystem flitting around before. I didn't realize, he had such a cool background in history, so I appreciated that. I appreciate listening to you geek out like that.
Yeah, totally. Yeah, I have the hugest crush on this man. He pops up in some interesting places. So he's not one of these individuals who is in the headlines, but you'll see snippets of him around. So he's actually if you read the O'Reilly book, Programming Rust, you'll see a quote from Raf like in the start, I think either on the cover or in like the preface. He's extremely influential, but also kind of under the radar a little bit, and ridiculously productive and an amazing Rust developer. Also, Xi Editor, the Xi Editor project, he has one of the biggest contributions of that was the development of a rope data structure that's extremely good. So Xi rope is awesome. I will pass the baton back to Sean, though, for your next pick.
Cool. The next one I picked was the post titled Over-Engineering a Fairly Simple Coding Challenge. This one was just kind of a fun one to read, in large part for me because I have kind of attempted some coding interviews in Rust before. Would not really recommend unless you are extremely confident in your Rust programming skills and are able to do it all, like, because a lot of like coding interviews are like, do it on a Google Doc or like do it on,
yeah, and there's no syntax highlighting,
right.
Like Yeah, and there's no like IntelliSense, so you're not going to be given hints on anything.
Yeah, and for me at least, it was painful. Probably some of the most painful interviews I've had. So I personally would not recommend just like stick with Python. Like don't burden yourself with the extra mental overhead, and when you're already trying to solve some algorithm problem.
Are you saying that like ridiculous whiteboard interviews are potentially like an overly stressful and artificial situation to put software developers through?
Yeah, and then add programming in Rust with no assistance on top. You know, you don't have the help with the compiler. Like that sounds really daunting. Anyways, so with that context in mind, this was just kind of a fun post to read. I have, you know, it is also interesting because I think with a lot of the kind of leak code style algorithm problems, whenever I think about solutions to them from a Rust perspective, the code that ends up coming out, if you want to, you know, do it idiomatically and with good, you know, best practices in Rust, they end up looking they end up looking much more engineered, I would say, than you know, if you just like wrote it in Python or whatever, right? It's like you do it in Python, it's just like here's the one function that just does exactly what the problem asks you to do. Whereas I think in Rust,
you basically think about the pseudocode or the algorithm that you would write. You write the thing.
Right. Like there are no abstractions. Right.
Yeah. Whereas Rust, you might want to create a trait or something, or like you want to do it really nicely. And it's like, oh, well, I need a new type because I wouldn't use an integer with like an I32 with a da-da-da-da.
Right, and that point exactly was actually highlighted in this post. So, you know, the author went through a couple of different iterations. Kind of their final iteration was rather made liberal use of unsafe, which was interesting. And so the author added an addendum though at the end, which I really enjoyed reading, which was like, hey, I got some feedback from readers of the code that I posted and got this feedback, and here's like a more idiomatic implementation. And they, you know, ripped out the unsafe parts and abstracted them into a type, and, you know, ended up having the final implementation be a lot cleaner and just idiomatic in that sense. It was even funny in the final pre-addendum code that the author posted. There was a call to dealloc just like at the end of the function. I saw that, I was like, oh, that's like very C style. Like, does that actually need to be there? Like, isn't the drop checker going to catch that? I'm not actually sure. But then in the post addendum code that did get ripped out, and now that seems like it's actually taking advantage of the drop checker with even an implementation of the drop trait specifically for that unsafe type that the author implemented. So that was pretty cool to see that evolution.
Totally. Did Alan, have you been stung with coding interviews before?
All the time. Like, actually, the one thing I don't like about coding interviews is when they ask you to read data in from standard in. I feel like I never do that. I don't know, maybe in Rust you might do that, but in normal life, you don't really do that so often. Usually you're building stuff with web, right? So I feel like sometimes they ask you to do things that are just ridiculous. It's a great This job is just about like converting what you have in Excel to a website, but you want me to solve some kind of computer science problem? Are you kidding me?
Yeah. So the thing that you get with coding interviews, well, in the elite code sort of style, you have one or two types of problems. One is an algorithmic thing, or you have read some data in, have like, how would you parse it? And then you've got to run some sort of analysis over the top. And like, so you implement, anyway, we should not derail ourselves even further. I was going to say, I am still nerd sniped about a coding interview I did probably 5 or 6 years ago for Canonical. And I'm still I keep thinking about it every so often, which is a streaming median. So the problem that you want to be able to, you want to create a data structure such that you can report out the streaming median, and there's no good way to do that as far as I can tell.
Clearly, you just haven't thought long enough about the problem yet.
Indeed, correct. Yeah, so actually, and there are trees, and I'm just like, that's wasteful, and there are other things because you have to keep two things in order. One is the sequence in which they arrived, because you need to drop things off, as well as the order in numeric value as well. Anyway, I shall stop digressing. Alan, did you have another pick?
Yes, this one's in a slightly different category, kind of more of a developer helpful friendly tool. RepliByte, which is so you know how you always have the perfect data in production, but you wish you could use that in your testing. But then you do that and you actually end up leaking information or maybe sending an email to somebody you probably shouldn't send them to. This is exactly what I believe is actually supposed to solve this problem, which is how can you take a backup of data, even transform the data so that way, like instead of using the person's real first and last name or email address, you can change it to something else and actually use it in development or a staging environment. And so to be honest, I had some people ask me to do this recently. I don't like to do it just because of those reasons I said before. You know, you might, biggest one is sending out emails, right? And you don't want to freak people out or send them to the wrong environment. And so this kind of tool I think is super useful. And as long as it's done correctly, which it seems to be, I think could be useful. So I may actually put this into use pretty soon.
Yeah, don't go leaking personal information, please. That's
especially if you need to be HIPAA compliant. That's the wrong thing to do.
Not HIPAA compliance, just your inner sense of being a good human should be driving you before the rules. No. I'm sure that you won't go and release credit card details or other personally identifying information.
If you're storing credit card details and you're playing around with these kind of tools, I think there's a problem, right? There's nothing wrong with the tool, but you'd have to have a lot more stuff, right? Storing credit card numbers is not something that is simple, right? So don't do that unless you're a professional. And most likely you're not. So
I just encrypt them by, I just, convert them to the closest number. So, instead of a 9, it's like after a G. What's after G? H? No, anyway, I shall carry on. Let's talk about data or generating data. So fixtures and tests and so forth, kind of because it floats back to testing. It's really, really hard to do right because sometimes you'll want to run your tests, say, under a clean database environment. Does this thing work with Postgres as well as SQLite? Because sometimes we are tempted to just run our tests in memory under a SQLite database versus like a production store.
Yeah, this one, it seems to be that it just works on Postgres, MySQL, and actually MongoDB, which is quite interesting. They don't actually specifically list out a table, which I thought was surprising unless I missed it. But they always list their examples in Postgres. And and to be honest, if you're going to be using multiple databases in the same project, I don't think it's a good idea because you're going to get different responses sometimes. Like there's, especially SQLite, right? There's less feature support in SQLite compared to other RDBMSs. So basically probably not SQLite, no.
Cool. Well, we'll circle back to me, I suppose. And my next choice was, and I've just written it down, was about securing crates. And so this post is a discussion about side channel attacks, which is interesting because we had an example of a side channel attack in the official update. So we talk about, so the post kind of illustrates things like, if you are a database library, if you're a database library, then you might need network access. But if you are implementing a data structure, you will never need the network. Like, this is just not something that you should do as someone who is implementing, let's say, a rope data structure, because we talked about text before. Or, you've got your red and black tree implementation, or you're inverting binary trees because you're doing coding interviews. Your crate does not need to access the file system. Like, it doesn't. That's something that's kind of a weird category error that we should be able to somehow avoid. And the post is I'm trying to just flash back to my notes, is just a really nice overview of the problem. And the example that they chose was, let's say that you've got an API, because in this case you're Stripe, because you're accepting payments. Now your own URL, so can't we restrict the crate down to only being able to access, the allow listed or the URLs or the hosts that are in your allow list? And this makes me think a lot about like capability-based security, because this is a kind of what the post appears to be hinting at, and made me think, well, there's this wonderful technology called WebAssembly. So one of the things that you probably not for a data structure crate, but if you want to provide an assurance that your code is reliable, if you want to be able to demonstrate to third parties or other people then you could actually write a WebAssembly module and actually define it as not being able to access the file system. I don't know if that's general purpose enough for arbitrary Rust, but it seems like being able to kind of put some petitions around or add some isolation to dependencies would be kind of this nice thing to do. I don't have a magic wand, unfortunately. Sean, do you have a magic wand?
Nope.
What about you, Alan? You're going to fix software problems?
I got something.
Yeah, right. It's a secret. But
yeah. It's called the magic within, right? If you believe in yourself, you can do
it. I will actually. Yeah. Okay. So what? How can we protect ourselves from side channel attacks? One of the things that you can do as a Rust developer is use the cargo vendor command. So the cargo vendor command will take all of your dependencies and store them locally inside your project directory, such that you can be sure that your project is verifying code that you know. Now, that isn't a complete defense, but it prevents you. It prevents someone updating the code and then pushing that towards you. If you wanted to be more restrictive, you could kind of verify that the changes were that they said they were and so forth. And kind of gives you another level of verification. And I had one other thought as well, that the other thing, if you're building production assets, do it in isolated CI environment so that you don't expose your code or your dependencies. They have no access to the production information that's stored in your database. Like, you should have a dedicated build machine that is kind of wiped and like you build things in containers so that there's no ability for your malicious dependencies to be able to infect or kind of sneak around inside your computer. Okay. I am going to change it up just because the order, because I want to talk about my next one because it ties in really, really nicely with security. I'm getting some nods. My last pick is given this kind of slightly, let's say, academic title, but actually it's very good content. So it's called Modeling Interconnected Social and Technical Risks in Open Source Software Ecosystems. This is a PDF that's up on the archive, written by William Schuller and Johannes Wachs, to European academics, presumably. And this is a attempt to model the fragility or the robustness of the software ecosystem that is crates.io. So if you were to remove one crate from the crates.io ecosystem, like how much of a cascade would that cause? Or if you were to introduce a security hole into one, like how bad would it be? And it turns out, like many things, that this is a power law distribution whereby a very small number of crates have a disproportionately large amount of importance on the rest of the ecosystem. And so and so there's a methodology for ranking crates in terms of their importance and making sure and providing a couple of mitigations. So making sure that these very significant crates are funded, that you have if you're a very large company, e.g. you're a gold or platinum member of the Rust Foundation, let's say, you could put some money into making sure those are maintained because they have a very large impact. It is an academic paper. It's a little bit dense, but it's also robust itself. It's got a very explicit methodology about how they provide this ranking algorithm, and it seems quite fascinating that we could have applied a quantitative approach to something that feels quite qualitative, like side channel checks and human behavior. Any thoughts from you two? No, that's good. By the way, if you're listening and you're like, I really want to shout at someone, feel free to email us at hello@rustationstation.org, and I'm sure John will forward me the note and say they hate you. Right. Okay. So who wants to go next? I've changed the order up. Now you guys get to change it as well. Any hands up?
Sure, I'll go. So the last post I picked was called Parsing/Recursive Descent Parser, which I think was a slightly curious name for the post, but I guess the author got the point across of it reflected what the post was going to be about. Anyway. This was a fun little post, and I actually, as an aside, really liked how the author, the aesthetics of this person's blog were quite pleasing, with the typeface that they picked, or the font, I should say, and I don't know, something about it was just. I
like that you distinguished font from typeface there. That was it shows some precision, which I appreciate.
I just mean how the characters looked, I think that was the correct word I used. I guess I'm not entirely sure, but anyway. So I guess what I wanted to say as far as this poster is concerned is I've sampled a fair number of tutorials that walk through like parsers, or even like little Lisp interpreters or compilers and things like that. Those are some of like my favorite sorts of content in the Rust ecosystem to read about. Funnily enough, there was another post in this week's issue, that was someone has been writing a MD book on implementing a Lisp interpreter in Rust, but I liked this one a little bit more, so I picked it instead. And I just liked how the author just took like a very small program, which was implementing a parser for like monetary format. So parsing like the currency symbol and the amount. Writing a little program for that, right? But they did a good job of walking through all of the main kind of concerns, right? Like, how are we going to model the data via data structures? What are kind of like the error handling concerns we want to talk about and encapsulate? Organizing helper methods, and all of that. So it was just a very kind of thorough end-to-end example from a very just kind of small and kind of easy to digest problem, right? And they even talk a little bit about Bacchus-Now reform. I mean, I guess they didn't specifically shout it out. They used the acronym BNF, but I knew what he was referring to.
Look, it's always easy when people only use the acronym.
Sure. But the post gave a nice little intuitive blurb of kind of how to think about the grammar for this problem, which I appreciated.
Alan, you strike me as someone who's like more of a regex kind of guy.
Depends on my mood, but yeah, usually. Sometimes I just use starts with and a string. Sometimes also works.
Yeah, I mean, you can actually get quite far with like finding matching on the first letter and then yeah. But so if I were to, is parsing something that you've played around with a bunch, Sean? Because I've tried it a couple of times for like weird micro formats that pop up, but it seems to me, and this is, I don't mean to be rude, so feel free to interrupt. It seems like an interest that computer scientists really spend a lot of time on. But how many times do you use a parser? It's really fascinating. But do we need another list? Like, do we need another calculator? Like, I don't know. Like,
I mean, I guess that depends on the domain you're working in, right? Like, I work in an environment where we pass around a lot of like RPC messages and stuff. I guess, we do a lot of serialization and deserialization with Serde. So that I know that happens a lot. Actually, don't do a lot of parsing work. I mean, there is a little bit. Mostly parsing, like writing little, programs to parse config files and things like that. So I think that's probably pretty common.
Yeah, and especially if you have bits of config that come in as strings, but actually that there's kind of you've got a key value pair, but that inside the value is kind of, there's something packed into that. That often happens, especially with config, right? Like you might want to say that, I don't know, you've got an option for size, and it might be small, medium, large, XL, let's say, and you actually want to convert that to a type. One of the other things that is available to you in Rust, instead of like reaching all the way for a parser library, is to just use the from_stir. Is it from stir trait?
I believe so. Yeah, I think so.
And you can kind of get these little baby parsers, and they're quite performant as well. And the example instead, you're going to say something?
Oh, I was going to say I also reach for the toml crate a lot, but these are mostly for like my own personal projects where if I need to parse some sort of configuration, I'll just be like, throw it in a toml and then we'll just use that to parse it. So that one's pretty nice. But I think to your earlier question of, what's with the fixation on parsing? Yeah, I don't know. I do find it kind of fascinating. And again, they are some of like they're one of the topics where if I see it crop up in a Rust tutorial, I almost always read it. Yeah, I don't know. It's
no, I can't
really put my finger on it. It is interesting.
And one thing that I appreciate about Rust is it really goes towards the parse don't validate method, like kind of design pattern is too strong, but philosophy, let's say, where instead of attempting to validate some user data, a more robust mechanism is to take the user data, parse it, convert it to some concrete type that you've predefined, and then the rest of your code is completely isolated from that user data. You want the user data to evaporate as fast as it can because you have something better. Alan, did you want to finish this up? Did you get a third?
I didn't end up choosing a third, but I will right now. And I'm going to be just looking at my own stuff. So I did release a podcast, Rust Safety with Quentin Ochem and Florian Gilcher. So we did talk a little bit earlier about embedded development, and this podcast does talk a lot about that and the verification process and Ada, the Ada programming language, Ada Core, the company, what they do with it, and also their recent working with Florian's company, Ferris Systems, and their version of Rust for safety. I forgot the name now, Ferricine. So if you're in that scene, if you're in embedded, if you need this kind of stuff, I think that's a great episode to check out. And I learned a lot about Ada, and I had no idea anything about Ada. I just thought it was some old programming language, but it seems to be, as Quentin actually said in the episode, basically, if you substitute Rust with the word Ada, you have the same. So you may want to check it out sometime.
Except Ada is much more in the Pascal heritage, where I'd say Rust is much more from the ML heritage, right?
Again, I quoted him, okay? So
okay, all right, right.
Me, okay? I just tell you what he told me.
No. You will be held accountable. No, the other thing about Ada that I really appreciate, which I have always wanted, again, I get nerds note about these really annoying things. Ada enables you to define a range type that is like a bounded set of integers at compile time. So, for example, we know that there are 12 months in a year. The 13th month of the year should never occur. And you can define a type at compile, and your program will actually ensure that you'll never hit the 13th month, even though you're actually using in Rust terminology, a U8 or a single byte to represent it. So that's one of the features that I kind of think is really cool. There's other things as well.
In Rust?
You can, but it's not part of the language, right? So you could definitely define like a month type, like it'd probably be an enum, but I don't know if you could say a range, not range in the sense of something that you iterate through to get from 1 to 12, but just a subset of numbers. So you know how a U8 is constrained between 0 and 255? Well, you can define some other number type which is constrained between two arbitrary some other numbers. And this is and if my Ada knowledge is pretty rudimentary, by the way, so I shouldn't be considered an expert. But my understanding is that if you compile Ada programs in debug mode, there'll be runtime checks, and if you compile them in release mode, or the equivalent of in Ada, the sophisticated Ada compilers will elide a lot of the runtime checks because it can guarantee that you'll never encounter invalid values. Yeah. At least that's my understanding. So if you have, feel free to get angry online. Like, that's what the social media is for. Like, there's a Twitter account there. I think it's Rustacean FM. There is also, the email address hello@rustaceanstation.org. Two little bits of pieces that I would like to shout out. One is the Rust C performance improved this week. We got faster. Yay! Go Rust C! So there's a little table about 2/3 or 3/4 of the way down the blog post, which has been a recent addition to the newsletter. The other thing to point out is that now meetups are in person again. You should go and check whether or not there's a meetup in your area, because there are dozens every week. Okay, and with that, we've hit the end of the episode. I appreciate your time. If you have feedback, please send it through. Otherwise, goodbye.